Hi, everyone. I hope everyone's having a good time tonight. So I'm going to tell you about sort of my unintended pathway towards becoming a woman in tech, which I never would have imagined when I was in high school that I would be doing what I'm doing today. I grew up in a really small town in Amherst, New Hampshire. Anyone from New Hampshire here? Yes! We're a rare species. What you see here, there's a village green. It's covered in snow. That's the field in the middle of town. I'm going to say the word village green later, so remember the field. And quaint town, you see beautiful blue skies, crystal clear night, stars. It's beautiful up there. And so I didn't really ever think about air pollution growing up. And then I moved. Where do I point? Am I going the wrong one? Aha. Okay, then I moved to Atlanta. And this isn't the most flattering picture of Atlanta on the left. It actually is a beautiful city at many times, but this isn't the best day for air quality. And I also spent a summer in Dalian, China, while I was a student at Georgia Tech. And I was a physics student at Georgia Tech when I began. I was 1 out of 30 in my class, and when I switched majors to civil engineering, they were very disappointed because I took them from 3% to 0 for my year at physics, and I joined civil engineering, which was more like maybe 40% female, a little more applied, and I was really interested in the air pollution engineering side of it, especially after spending a summer in Dalian where I didn't see blue skies very much at all. And it really woke me up to curiosity about what was this, what were all the issues surrounding it, what was all the physics and biology and meteorology. It's a sort of a confluence of many different fields of science to study air pollution. So then I dove in really deep, and I stayed at Georgia Tech. I'm a purebred all the way through to a PhD, and I did a PhD in environmental engineering, and I went right back to China, and I was in southern China measuring air pollution the hard way, which is really the gold standard. You vacuum air through filters, and you can see these circles on the bottom here. Those were originally white, and after 24 hours of pulling air through, in China, some of them were black, and you can analyze those in a lab. And it's a lot of effort to collect data this way. You don't get many samples for a given period of time, a lot of manual labor. And that wasn't hard enough, so I went a little bit harder. And then, back. Can I go back? And back. And forwards. Okay, then we went to Summit, Greenland. This is the highest point of the Greenland ice sheet. It's about 2 miles thick of ice and snow. It was about -40 in the spring, and it moved to maybe a balmy -20 in the middle of the summer. And we were also measuring air pollution the hard way. We had also collecting samples onto filters, but now we had to measure for about 3 days to get one sample because there were so few particles in the air. And we also measured air pollution in the snow. This is me, can you tell? It's a good look for me. What I'm doing there is I'm digging in the snow and going back through years of snow. And eventually, the really hardcore people do the ice cores, and you can go back over 100,000 years on the Greenland ice sheet and look at the air pollution going way, way, way back. So this was a lot of work. And then I moved to the Environmental Protection Agency, just about maybe a mile away from here. And we have most of the air pollution research in the country done here in the Triangle. And the regulatory way of measuring the air is using very rigorous methods. They need to hold up legal standards. There's big implications when you get the concentrations below or above the standards, and so this is also done in a really rigorous way. There's actually one of these, if you drive towards Raleigh on your way home and you look on the north side of 40, you'll see one of these stations. It's right next to the highway. It's right by the airport. And this is sort of the way that regulatory monitoring is done around the country. It takes a lot of effort, it's costly, and there's only so many in a given area. There's about 2 stations in the Triangle that are measuring particles. There's a couple more measuring some gases. And as part of my research, I'm a researcher at EPA, and some of my research was thinking about how can we measure air pollution in more places, how can we make it easier, can we make it less expensive, could we make it approachable to the public? So far, you haven't seen really it being engaging to the public in any way. And also, for the research use of data, maybe not regulatory, can we sacrifice a bit on data quality to meet some of these other objectives? And so my first project at EPA, this is where I sort of started falling into technology development, was creating a mobile monitoring car. This was a PT Cruiser, it's an electric car. It was actually retrofitted by NASCAR engineers in Mooresville, North Carolina to be an electric car. It was pretty cool. And it was we filled it with very high-end air monitors, not easy to operate, very expensive, but can do really cool things and can measure air pollution very accurately every second. And we took it, it goes all over the country still. It's currently in San Francisco. This is it mapping air pollution around Las Vegas. On this graph, there's higher concentrations on the highway, lower levels, other areas. So air pollution varies quite a bit in small geographic areas. And this is a great vehicle, but it can only be used in one place at a time. You still need a driver. You still need someone highly technical to operate it. And we thought about, could we do it in other ways? So this was one of my babies, the Village Green project. Think back to the Village Green. We thought, how could we make a station that you could put in a community environment like a Village Green that could collect data more autonomously? And there's actually one of these just down the road from here at the Durham South Regional Library. That was our first prototype. It's a solar-powered park bench. In this case, this one in Kansas City is solar and wind powered, measuring weather and air pollution every minute. And there's hidden instruments inside. We now have 7 of them in the country that are operating. We have 1 in Hong Kong through an international partnership. And it's been a really exciting project that many of us down the road at EPA have been working hard on. And then finally, this is the website if anyone wants to check it out, airnow.gov/villagegreen. You can check the data. It updates every minute. And you can see the readings at 7 places right now. More to come. And then finally, we are now getting into even more personalized, hands-on types of monitoring. We're developing miniaturized, portable sensor systems. And this is a project right now called the Air Mapper. This is playing with it at our house. This is we actually hacked a bicycle commuter handlebar bag we added. It has an Arduino board if people are into open source microprocessors. It has some low-cost air sensors, a touch screen, and it records data in a format that you can plug into a free data visualization website. And that's my 6-year-old playing with it. He was a really good test case. And he has to keep it, so I felt like that was a success. And so that is it for me and my story of how I ended up accidentally in technology. And there's a lot of people who've contributed to everything I've shown here. So thank you.